Well, that's probably not good.
Hey guys, welcome to Elevated Systems. I'm your host CJ. I was going to start this video by showing you this great deal I got on the used GTX 1080 and explain how you don't have to be afraid of something like a used mining card, especially considering the deals you can find. I was going to say all that, but then I received this dead GTX 1080. Now, honestly, of the many mining cards I've purchased, this is the first inoperable card I've got, and it's very possible I can still resurrect this card. However, thanks to eBay's buyer protection, I'm just returning it for a full refund. Tampering with it could void the protection, so I'm just going to put it back in the box. The problem I'm left with now is not only do I not have a GPU for my upcoming Threadripper build, but I also have nothing to refurbish in this video, right here, that you're watching, like right now. Except, I do still have this card from the computer FedEx broke. You can check that video out right here if you haven't seen it. Now, this RX 580 might not be as big and sexy as the ROG Strix card over there, but it is just as old and probably in need of some TLC. So today, I'm going to show you how I refurbish old graphics cards. So the first thing I'm going to do is completely disassemble this graphics card. Now, this video is about how to refurbish a card, not on disassembly, because every card is different. It seems like with every new generation of card, they don't just add more cores and clock speeds, but more screws, like lots of screws. Anyway, let's get this thing torn apart. Now that it's apart, let's look at the primary purpose of tearing a graphics card apart like this. The thermal interface material, or TIM. Now on this card there are a few different types of TIM. There are two types of thermal pads at various thicknesses, and there is of course the thermal paste between the GPU die and the cold plate of the heatsink. Starting with the thermal pads over the memory and power delivery, these pads actually appear to be in pretty good shape. What can happen over time, and something you may have seen, is these pads begin to, well, leak. That is, you'll see oil start to leak from the pads onto your card. Now, while this oil isn't harmful, the problem is this is actually your thermal pad breaking down, resulting in it not working as efficiently as it should. These ones seem to be fine and probably don't even need to be replaced, but I'm gonna do it anyway. The next and more important is the GPU thermal paste. Two things happen here. First, over time this paste dries out or cures. When this happens, the paste can actually act as an insulator, which is bad. Second, the paste actually pumps out of the space between the die and the cold plate. You know, the place it's supposed to be? This action is literally known as pump out. What happens is, as your copper or aluminum cold plate heats up and cools down, it expands and contracts. The GPU die also does the same, but not really as significantly because the thermal expansion coefficient of silicone is about 6 times lower than copper and like 9 times lower than aluminum. Anyway, as this expansion and contraction continues, it actually pumps out the thermal paste. This is in fact one of the reasons coolers are attached to the GPU and CPUs with spring-loaded screws. As the paste thins out, the cold plate is forced closer to the die or IHS. But eventually you can end up with no TIM in there, which is not good when it comes to cooling. Here's an extreme example of this on a mobile CPU of a laptop I refurbished a while back. There was literally no thermal paste left on the die. It had all pumped out. Anyway, I'm going to start by pulling off these old thermal pads and cleaning off the old paste. Now, I didn't show you how to pull apart this MSI card because, like I said, every card is different. But I am going to show you how to disassemble the fans because it works the same for almost every GPU cooling fan. So to start with, I'm going to remove this sticker on the back of the fan. I'll use some heat to make it easier. Now that the sticker is off, inside this little hole is a retaining clip and washer that connects the axle of the fan blades and keeps them attached to the housing in the motor. I'm going to carefully remove that clip and set it aside right here so I don't lose it. Now, the fan blade should slide right off. Now I'll be able to thoroughly clean the blades and the motor and relubricate it. Okay, it's time to clean everything. So that means we need to move locations. Welcome to my kitchen. We're here, well, because there's a sink and I'm not hauling buckets of water up to the geek cave. To start, let's take a look at some of the tools and supplies I'll be using to clean up these parts. We have some distilled water, some Simple Green all-purpose cleaner, isopropyl alcohol, baking soda, and we have some quick dry electronics cleaner. For supplies, I have a soft bristle toothbrush. I also have a soft bristle paintbrush that I cut down to about 1 inch in length, some cotton swabs, some lint-free cloths, and some gauze pads. I also have an air compressor, but a can of air duster will work just fine also. Okay, to start, I'm going to place the heatsink in a container of some warm water and Simple Green to soak while I work on the rest of the parts. Just set this aside over here. You can blow the dust out first if you would like. However, the cleaning solution will take care of it. Plus, I don't want dust all over my kitchen. However, I am going to blow off the PCB. Okay, next I'm going to mix some of the baking soda with some deionized water into a paste. Okay, with this cotton swabs, what I'm going to do is I'm going to apply some of this paste to any of the areas on the PCB that may have some corrosion or appear dirty. With this card, there are some spots with some corrosion, but overall it doesn't look too bad. In extreme cases, the corrosion can spread across the PCB, and because in most cases it's electrolytic or galvanic corrosion, it is conductive and can possibly short out your card. Now, both of these are caused by ionic contamination, most commonly in humid environments, moist air, electronic circuit boards, bad mix over time. If you have a nice beachfront villa, you might want to do this more often. I'm just saying. I'm also going to apply some to the PCIe interface connectors and scrub them just a little. Now you don't really have to scrub. It's actually the alkalinity of the baking soda itself that's removing the oxidation from the metal parts. Now, you can also use a pencil eraser to do this. However, not all erasers are created equal, and if you use one that's too coarse, you could damage parts, especially the gold connectors. now that the baking soda is dried, I'm just gonna get a little bit of my distilled water. And take a lint-free cloth, set that there. And my soft bristle toothbrush that I'm just gonna get a little damp. And then I'm just gonna brush away very carefully the baking soda. And you can see how nice and shiny those gold connectors now are. They look really good. All right, they were really kind of tarnished. I'm also gonna brush away from the solder points, but be very careful while doing this because you want to avoid the surface mounts on the PCB. Those are pretty easy to snap off of there, so be gentle. All right, now that the corrosion and oxidation is taken care of, it's time to clean this whole PCB. So, to the sink. Okay, now I got the card in the sink. What I'm gonna do is I'm gonna spray this entire card down with Simple Green. Now yes, this is water-based. Yes, it is conductive. And yes, you can put it on a graphics card. Because there's nothing to conduct. There's no power being delivered to this card, so no way to short it out. But I do have news for you. You've probably put conductive liquids in or on your PC before. You were just led to believe that they weren't conductive. More to come on that in a future video. But yes, this is for really extreme cases. This card probably did not need this level of cleaning. This is for when a card is horribly dusty, dirty, grimy, when those thermal pads have really leaked all over your PCB. Now you can use something like this electronic cleaner to clean the whole PCB, but I find that this is actually even more overkill. This stuff is a lot harsher than something like Simple Green. Not to mention, you have to do it outside or in a really well ventilated area. Okay, now that I got it sprayed down, what I'm gonna do is I'm gonna use this soft bristle paintbrush to basically just scrub down the whole card. Now, again, you want to be very gentle. These surface mounts can dislodge from this board, especially the ones on the GPU chip itself. I'm not going to scrub those, but I am going to hit the memory modules. All right, the power delivery, VRM. All right. Also the back of the board. The back of the board was actually the part that had a little more corrosion. But those terminals and connectors are looking really nice. Just get some of the grime out of the back of the core. Again, very careful here. This is a very soft bristle brush. But even soft bristle brushes can dislodge some of these surface mounts. All right, that'll do it. I'm just going to spray it down a little more here. And then once I got it sprayed down, I'm going to rinse it all off completely with my distilled water. Okay, but I don't want to pour the water directly into my display ports or my power plug there. But I am going to clean those out in a second. That should do it. Let's take it back over here. I'm gonna lay it out on some of my lint-free cloths. Okay, I'm gonna use the gauze pads to dab off most of the water. Again, carefully, you don't wanna wipe, you just want to dab. You wanna get most of the water off the board. I use high quality gauze pads here because they're very highly absorbent, and these ones are lint free. They're not gonna get lint on here, and they're also not going to grab on to these surface mounts and rip them off, which can happen with, like, if you try to use something like a microfiber cloth or sometimes even a shop towel, you can tear off some of these surface mounts just by dabbing them. Okay, and then I'm gonna use my compressor again to blow off most of the water. Okay, now that the board's clean and pretty much completely dry, I'm going to use my quick drying electronics cleaner to clean out the HDMI and display ports as well as the power plug here. However, I'm going to do that outside because I actually use this kitchen every day to cook my family food. I mean, this isn't Linus Tech Tips here. So, I'm going to do that. I'll be right back. Okay, so the board's mostly dry, but to ensure it's completely dry, I preheated the oven to about 200 degrees, and with the board blocked up on a baking sheet, I'm gonna turn the oven off, and then I'm gonna place the board in the oven and leave it in to dry for about 3 hours. Now, this is not the same as the oven method of resurrecting a dead graphics card. That requires a lot more heat and something I just don't do. Now, if your GPU starts throwing artifacts, there are lots of videos and articles out there on how to reflow the solder connecting the GPU to the PCB. You can watch them and try it, and it might even work until it doesn't. Here's the problem. The same thermal expansion that pumps out the TIM on your chip also wears out the solder of the ball grid array that connects the GPU to the PCB. When these solder points crack, those cracks also begin to oxidize, and just reheating the solder will not remove the oxidation. You would need to apply flux, not something that's easy to do under the GPU. So the solder may reflow enough to get the card working temporarily, but as soon as you start thermal cycling it again, those cracks are just gonna open back up. The only way to truly and completely refurbish a graphics card is by reballing the GPU. And ain't nobody got time for that. So here's a tip. If someone's trying to sell you a factory refurbished card, ask them if it's been reballed. In most cases, these refurbished cards have only been cleaned just like I showed you here. If you're lucky, it may have been ultrasonically cleaned, but that's pushing it. But listen, if you got a dead card with an expired warranty, by all means, chuck it in the oven, because really, what do you got to lose, and it might work. Okay, while the card's drying, let's work on the other components. Okay, so I got the heatsink, and it's been soaking for a while, so I'm just gonna, with some warm water. All right, this isn't an electronic component, so tap water's not a big deal. I'm just gonna rinse it out really well. And then a final rinse with some of the distilled water. I also, off camera, put the fan blades in that same bucket of cleaning solution. I can just rinse those off too. Okay, now that I've cleaned and dried the heatsink, I want to inspect it because just like the solder points on your PCB, there are solder points on the heatsink where the fins connect to the heat pipes. And just like the PCB, thermal expansion and contraction can cause these solder points to fail over time. Now, if a fin or two comes loose, it's not a big deal. However, if there's a breach or a hole in the heat pipe, that's a problem. Heat pipes use liquid to transfer heat away from the source to the fins. If the tube is compromised, the liquid evaporates into the air and no more cooling. Depending on the heat sink, this may or may not be easy to see. In most cases, it can be detected by taking direct temperature readings of the heat pipes at different points along the cooling loop. If one of the heat pipes is significantly cooler than the others, it could be broken. So one of the ways to inspect it like this, if you just take and you slide your fingers along the path of the fins where they connect to the heat pipe. Now the fins may move slightly, they may flex back and forth. However, you will feel one move and actually slide across the heat pipe where it may be disconnected. There may be one right here. It's just a little loose, but again, not a big deal unless there's a breach in this heat pipe. But these heat pipes are nickel-plated copper, and it's very unlikely that it's going to breach. So we should be okay. Okay, so now we're gonna move on to the fan motors. Now, I've already blown these out with the dust. Again, these look like they're in pretty good shape, but again, I'm gonna take these outside and hit them with some of my electronics cleaner just to get them nice and clean. Okay, now everything is clean and dry. We're back in the Geek Cave and ready to reassemble. I'm gonna start with the fans. Since I cleaned off the small amount of grease that was in there, I just need to reapply a little bit. I use this CRC dielectric grease. It works great on these brushless fans. In fact, it's probably the exact grease I washed off of this to begin with. So let's get it. Just a little will do. Because these are magnetic fans, they're pretty much frictionless. So this grease is more about just protecting the metallic surfaces from corrosion. But we do want to get some on the axle here. Just a little bit. Okay, anyway, now that that's done, I guess I can just cue the speed montage, or I guess I can just play the first one in reverse. Anyway, let's roll. All right, fan, shroud, and heatsink have been reassembled. Now let's reapply our TIM. I'll start by cutting some thermal pads to size. I use Arctic brand thermal pad. It comes in about a 15 centimeter square. I have both 0.5 millimeter and 1 millimeter thickness. I like this stuff, it works pretty good. It has a thermal conductivity K value of 6 or 6 watts per meter Kelvin, which isn't bad considering the Cryonaut paste I'm going to use is about 12 or 13 K value. I think this is the same thermal pad material I pulled off the card. Good heat transfer and doesn't leak oil. Okay, so I got my thermal pads and my heatsink reapplied. I actually saved a couple of the thermal pads because I just don't have anything nearly that thick, and it was in perfect shape. So why not reuse, recycle, right? Next is to repaste the GPU die. Now, after several years of experimenting, I used 3 types of thermal compounds. For die to cooler contact, like this example, the heatsink directly on the naked die, I used Thermal Grizzly Cryonaut. So for between an IHS and cooler, like a standard CPU install, I use Noctua NTH1, or now the NTH2. And between the IHS and die, as in when I delit a CPU, I use Thermal Grizzly Conductinaut, their liquid metal compound. Now, while liquid metal might seem like a good choice in this instance, it's really not. First, this has a partially aluminum cold plate, and liquid metal eats right through aluminum. And even if it was copper, unlike inside a CPU IHS, the die and heatsink here are not sealed together. They just sit on top. And the die itself is not perfectly flat. It actually rounds slightly. So there is the possibility, however slight, liquid metal can drip out and end up somewhere it shouldn't be. With the Cryonaut here, I can just spread on a nice thin layer over the entire die. I always recommend this method with a naked die. If you just plop a dot of paste in the center, it could either take some time to completely spread out or never cover the entire die. And you want full coverage of the die to ensure best possible heat transfer. All right, so now I got a nice, thin, even coat across the entire die. Let's screw this puppy back together and get it plugged in and tested. Okay. It's reassembled. Ready to go. All that's left to do is plug it into my test bench here, aka motherboard on a box, and see if she works. Let's get some power delivered. All right, first test. Power supply is on. Nothing blew up. Let's get the monitor plugged in. And let's go ahead and fire it up. Fans are spinning. I might have probably should have turned this the other way so you can see that, but the fans are spinning here. Voila! See, a gallon of water and still going strong. Let's just fire up heaven. All right, so running heaven under load, fans are ramping up. All right. Still at 40, 44, 100%. It's still going strong. So it looks good. I did some benchmarking on this card before I cleaned it up. Now I'm gonna do all that all over again so we can compare. Okay, it's actually the next day. The results are in, and the results were better than I expected. I knew there were some issues with the card because during my initial testing, I wasn't able to run either Furmark or the AIDA64 GPU stress test at the card's default settings. Both tests immediately crashed the system on launch. After the refurb, both tests ran without issues, with Furmark only producing max temps of 66 degrees Celsius and an AIDA64 temp of only 63 degrees Celsius. Additionally, the card's idle temp was reduced by 45% from 38 degrees Celsius to 24 degrees Celsius. 45%. My guess on why such a huge difference is at lower temperatures there were more gaps between the die and the heatsink due to pump out. So the thermal transfer efficiency was much lower, but when the GPU heated up, things started to expand, closing the gaps and actually increasing thermal transfer efficiency. I mean, just a guess. Another issue I had pre-refurb was I wasn't able to achieve a stable overclock on the card at all. At most, I was able to get about plus 50 megahertz on the core clock and plus 200 megahertz on the memory while running Heaven. However, as soon as I fired up TIMESPY, the system would just eventually crash. However, post-refurb, I was able to achieve a modest but stable overclock of plus 104 megahertz core clock and plus 250 megahertz memory clock. This is the point where I hit the card's voltage limit of 1.25 volts. Let's take a look at the rest of the testing results. Pre and post refurb tests were conducted at the card's default voltage, power, and clock settings, as well as the default van curve. Overclock settings included a 100 millivolt increase to core voltage, 50% increase to power limit, a core clock of plus 104 megahertz increasing from 1366 megahertz to 1470 megahertz, and a memory clock increase of 250 megahertz increasing from 1500 megahertz to 1750 megahertz. The default fan curve was maintained. Starting with a 15-minute run on Heaven, you can see that although power utilization remained relatively unchanged pre and post refurb, max temps dropped by 10%. With the overclock, power utilization rose 28%, but max temps only went up a single degree. Moving to Firestrike, the results are practically identical. Scores recorded are graphic scores only. You'll notice that although there was an 11% temperature drop, the pre and post scores are relatively unchanged. This is due to the card being power limited at default settings. And even at the higher temp, it's able to maintain its max clock speed of 1366 megahertz. However, when overclocked, the power limit is increased and scores improved by 9%, while still only a 1 degree temperature increase. The Shadow of the Tomb Raider benchmark shows an 8% temperature decrease while FPS remained the same, and a 2 degree temperature rise, but 7% gain in frame rate while overclocked. Finally, TIMESPY shows us some of our most significant improvements as we achieve a 4.5% bump in our graphics score while dropping temps by nearly 10% post versus pre-refurb. Overclocking achieves a 13% graphics score bump with only a 2 degree temp increase. So, what do all these numbers mean? First and foremost, we are definitely more efficiently removing heat from the GPU. When you see temps drop, even when power levels increase, that means the cooling performance of the GPU was improved. Now, this may have been accomplished by just repasting the card and skipping the whole trip to the sink. However, there was definitely something else going on with the card, seeing as it immediately crashed in Firmark and AIDA64 before it even had a chance to heat up. This card has plenty of thermal headroom. If it wasn't for the voltage limit, I could push it much farther. There are ways around that, but that's not for today. So, for those of you with an old tired card who are still trying to suck every possible frame out of it, maybe time to give it a bath. Anyway, that's it for today's video. I hope you learned something. That's always my primary goal. If you have a question, ask. I'll answer it. If you like this video, you know what to do. And the best way you can support a small channel like mine is by subscribing. You can also check out some of my other videos. And until next time, have a great week.